in a few minutes when we get to the demo section. This is the most mind-melting demo that you are going to see, despite the least Linuxy title of any session here. This applies to both platforms, but we primarily are a Windows shop. I'd say 90%, but Linux is growing and increasing market share across our environment. But we've done some we think they're pretty interesting things. We've solved a lot of problems and a little bit further down the road than a couple of the other sessions that I've been in so far. So hopefully this is useful to you. And most of this at the end will be Q&A, because we've got a lot of other topics we possibly could have covered, but we chose kind of our big ones. Go next one. So this is really talking about breaking the new ground. So one of our challenges is managing Windows at scale and speed. So that's just a challenge, because Microsoft makes a really good operating system, and they have for years and years, but the tools to manage it are hit and miss would be a compliment to some of the tools that Microsoft provides to manage their OS. And that goes back to MS-DOS, right? Great operating systems, but the tools to manage them, not so much. And we have a really complicated support model, because someone was speaking about this in another session. We're the big E in enterprise, right? So we have a lot of different groups that have very segregated roles and responsibilities, and Windows is still in the method pretty much. There's some exceptions, but everything wants you to be in the local admins group, so that's pretty challenging. Auditors really don't like that. One of the problems that we have is primarily we're Windows. So we're not going to give someone who's been a seasoned Windows professional access to the Salt CLI. Too much damage can be done. Typo can take you out. You can read about all that in the paper from other companies where that's kind of occurred due to typos or people not being educated on the tools. In order to get people up to where they kind of need to be to feel comfortable, we had to kind of invent some other things. And we've also had a lot of challenges around the repositories for Windows. So as that's gotten better over time, but we're slowly maturing into some of that. So we're not a shop that's been able to take advantage of a lot of third-party things due to contractual limitations, contractual languages, licenses, agreements. We got a lot of stuff like that. If you work in a larger company, that's a pain that we probably all feel collectively when it comes to bringing in new tools that can be very difficult. So we kind of had to do a roll your own strategy on what we're using for a repository rather than something that was more commercial or out of the box. In this way, Linux works much better for this because there's a provided repository for any flavor of Linux that you might possibly want to use. But those and the process of installing and patching using things like RPM and apt-get, they're a lot more mature. Linux has its own problems, but in regard to repository, those is pretty much solved. So, looking forward, what we want to be able to do is have 100% success. When somebody hits something, we want it to go. When we patch something, we want it to go. We want to do it, we want to do it at speed. And 98% is not good enough. With an environment our scale, 99.5% is not good enough. Just with the number of servers, chasing down why 400 of them didn't work out of 12,000 is still an entire evening's worth of work. So interesting, a little background on us. We're the land of maybe 15,000 servers and 4,000 separate applications written by potentially 6,000 different vendors. So we have a very diverse environment. We are not always creating a new .NET project for a developer or a new Python project for a developer and rolling that infrastructure. It can be every single business intelligence tool that you can possibly think of, coupled with some Microsoft technology. Maybe they've mixed in some open source. So it's very challenging, very diverse, different networks, different firewall rules. Everything's different. Lots of special snowflakes. So we don't have that kind of cloud level standardization where we have one platform we're running and everybody just jumps on board. It's not kind of the reality we live in. Next. So we did a whole bunch of different stuff. We put in SaltStack. Yay. Was not easy. Our environment is very heavily firewalled. And getting everything to talk to everything was a problem that had not been solved until we kind of came on board. So that gives you an idea of what our automation strategy had to be, was kind of ground up, but it had to apply to legacy systems. So when we talk about what greenfield looks like, I don't really know what that looks like because most of our environment is legacy or is still kind of being built like legacy. We have a go forward platform, it's much the same as the last session that I sat in. That's a nice world to live in. If you can get there, then yeah, let me know how you did that. But the majority of the stuff that we have, though we do have a big velocity of coming in new, is really adding to existing. So interesting. And we had a lot of separation of duties problems, same thing. So we ended up having to take core and customize the API. And all of these technologies are great, right? In and of themselves, every technology is good for the people that know and understand it. But downstream, the people that take the technology and use it are only capable of learning new technology at a certain rate. And much like the book, The Goal of the Phoenix Project, you're bottlenecked at how fast you can train up the lowest, newest, most green employee on the technology to make it fully multiplicative and effective for your audience. So what's very important is that we have a lot of tools. You'll see a whole bunch of different tools that we use. Those are limited in effectiveness by how well they can be comprehended by the admins that do the work and then used to determine decision trees, effectiveness, and action. So that's a problem that we have. But all our Windows admins know the MMC, right? Everything happens there. Active Directory happens there. Start and services happens there. All that good stuff happens there. So we kind of looked at that as being probably a more familiar interface, certainly more than PuTTY, right? And my hardcore Linux guys that work on my team bemoan their use of PuTTY and die for Macintosh computers as a result. So we also have a PowerShell module that we wrote. Does lots of stuff. But basically what it does is it buries all the ugliness of PowerShell into a module and keeps all of the top-level wrapper stuff human readable. So any admin can go read a script. They don't really have to know PowerShell. It's kind of all in plain English. We have some style guides that eliminate things like the $_ and things like that. So anybody who's even new to PowerShell could pick it up and kind of read through the code, provided they have a basic understanding of a programming language and speak English. So that's kind of the deal. And then we have a luxury that a lot of folks, at least at the last conf that I talked to, don't have, which is we have a gigantic implementation of Splunk. I wouldn't say it's the world's largest after talking to Splunk. There are certainly larger installations than ours. But we use it, and we use it effectively. So anything from internal dashboarding of applications and application tracking and performance to our own stuff. And I would say that increasingly, we are not the heaviest users of Splunk inside our organization, but we definitely were the early adopters. It also helps that my team supports and deploys Splunk. So we loaded the deck for ourselves. And this is kind of the problem statement that we started out with, which was, our level 1, network operations center, level 1 admins, most of what they do is rebooting, restarting, stuff that you'd expect that Windows likes to do to fix itself. Those of you in Linux land, we could get into a finer point about what exactly causes Windows to crash. Most of the time it's bad code, but at the same time, restart and reboot usually solves the problem in a pretty expedient amount of time. And level 2 administrators are doing like a bunch of different system level maintenance stuff. Upgrade an application on 145 servers that are all the same. And they're giving out dates that are weeks, we're giving out dates that are minutes, right? So we've used Salt to do a lot of those different kinds of use cases. In fact, we get pulled back in when timelines look like they're a little bit out of whack, and we usually come in and save the day for a project. And then we also use Splunk and Salt, a combination of them, for doing a lot of auditing work. So you maybe are one of our clients and want to know, who has access to my data? Do contractors have access to my data? Do they not have access to my data? How many people are admins on all the stuff that I have? How many people have read access to the database? How many people can write the database? Who can write how is the change management? Like all of those kind of audit questions that bother enterprise companies. If you've ever been in an environment that had an external audit, we have them going on constantly all the time, perhaps more than 12 at a time. Okay, so sometimes, because they're triggered by new business, People want to see a clean audit before they'll sign a contract. They're triggered by contract renewals. They're triggered by contract requirements that say we have to do it once a year, and then we have our own internal audit, and we have our own external audit for the entire shooting match. So you can imagine doing audit, yeah, it's a big job for us. And it's part of what our value proposition is, right? So that's that. And then looking at the next slide, we have some ongoing challenges. It's not all rosy, right? I talked about we have legacy systems, but we have a lot of systems that are restricted environments that can't be managed, so we have SALT islands for dealing with stuff like HIPAA data and any kind of personally identifiable data. So we also have problems with like a lot of concurrent execution at scale. I think we're actually kind of beat on solving some of that by attending, so that's good. And looking at our job submission and the results recorded with the returner, like I said, our network's very complex. We have a lot of firewalls. We've got a lot of potential bottlenecks in our system in terms of the network. So oftentimes we're sending jobs with large timeouts, and sometimes the returner isn't as reliable as it could be. But we do manage and return the results. Some of the other things that we have, in our environment, the SALT minion needs constant vigilance because of kind of these network bugaboos that we have once in a while. So I have a team that uses Splunk to manage hygiene of all the agents. So we have several other agents for security, management, inventory, and otherwise that we have a team of people constantly vigilant watching that for 15,000, 16,000 servers. And then executing CLI commands really do require access to the SALT master and some level of sudo, so we have that kind of restricted down into just a core team. So, and I already talked about, we got Windows people operating in a Linux world, so that's like danger, right? So what we really needed to do was get down to a GUI that has clicky, right? Like, let's just break it down right where you need it. It's just got clicky, right? Nobody who's doing things at scale would be using this. This is more one-off stuff, but it keeps the power away from people who could do damage unintentionally. So it's kind of saving some of our users from themselves and compartmentalizing down what they can do, make sure it's audited and tracked, that kind of bit. And we talked about it cross-platform, of course. We also hooked into role-based access control because PAM wasn't going to be an effective method of authorization for our security team. Something about that didn't feel good to them. Wonder what that would be. And we don't like managing local passwords on local machines. So we hooked it into our AD, which is really our single sign-on environment. We have a bunch of tools that surround that, but to do SAML and OAuth and other things. But in our case, we just went straight native AD. And then we also did some enhancements to the Windows Update module. A lot of those have already been carried forward in the newer versions of SALT. We're not completely on the newest version of SALT yet, and we're looking forward to the improvements that have been made, but we had to make some tactical updates to that. Because we were patching with a script primarily, and it was writing to a certain place in the event log using our module, which is great. So like it's all cool when you can log it all into the same place in the event log, and it all comes into Splunk, and it all free flows, and you don't have to do anything to Splunk, and like that's great. So we had to add some logging to the Windows Update module so that when we moved to the Windows Update module from our like homegrown patching stuff, that it all flowed. And I'll show you we'll show you why that was important when it came to Splunk, because we have a lot of instrumentation around those kind of logs. And then same thing, central reporting. So others have talked about this in their sessions, but really taking the returners and all the logs in the bus and all that good stuff and slamming it into Splunk, right? Some people, I think at the last conf, were using Elk to do that. And I heard the Elasticsearch returner is broken. They probably fixed it by now, but that was last year. So that's what we got there. And then, so here's what we're going to give you in the demo. Got a real simple GUI. It's an MMC. We use a SALT API to hit it. We've done some customizations to that, and Hoy will take you through that. And then all the external control, the modules, and then looking at how we watch what's happening in real time. And with that, I'll turn it to Hoy.
Okay, I hope you guys not falling to sleep yet. Right? So I don't have any live demo. What I have is just some pre-recorded video Doing live demo is dangerous. As you may know, things may work and things may not work. So I'm going to show you a video from our lab, a trimmed down version. So let me pull up the video first. All right, I can't see it, but I'll just try to maximize the screen. So as Dave mentions, we actually, the GUI part, let's start with the GUI. Maybe just go over all the component pieces we have. The top layer is a GUI written in Microsoft Management Console. As you see on the screen, maybe I'll pause the video just a second. Can't see the screen. Yeah, how do you do that? Apologize for, okay, just give me 1 second. So at the top, we have an MMC, basically Microsoft Management Console, and then we'll go through the Salt API, we'll hit the system. And then with Salt API, we also hook up with AD, and as Dave mentioned, we have a role-based access using Salt itself has this access control system. I'll go over some of the stuff that we have. It works. Some of the stuff that is still missing. So we actually have to monkey patch a few modules to get it working. And then the last part is when Dave mentions we have 14,000. I think we could have more systems in our estate. So if I push a window update events to 1,000 minions, what happened? Which one failed? Which one's timeout? Which one actually is finished successfully? It's hard for us to tell, right? So we roll a simple returner. We'll just look through those code and basically aggregate all the logs, and then we'll ship it into Splunk, and then we do all the data mining in Splunk, and then we'll go a little dashboard to show how it works. So, okay, we can start. All right, so this is the MMC, Microsoft Management Console. First, I just want to get rid of some of the screen because it's too small. And the next thing we have is we add a plugin here, right? Add the snap-in. So we wrote this ourselves. Dave started the code first, and I just fill in all the pieces. And when it started, we'll ask you for where your Salt master's URL is located. So we add the one in the lab, click OK. Nothing is shown at this point, nothing, right? So the next step we need the person to do is to log in, right? So you may move fast forward a little bit. Yeah, yep, so it will ask you to log in. This is in the lab, so I just log in, punching my username, and the login is going through LDAP. And after you log in, can you pause for a second? Basically, this is showing you what you have in salt key, right? If you type salt key -L, capital L, give you a list of minions accepted, and accepted, reject, deny. So we broke those. We broke it down into these 4 categories. Yep, we can continue, and then we got to look into those minions that accepted, because I'm just mimicking a NOC guy. Just want to restart the service, right? You can expand this tree. You can have 1,000 minions here. You can look it up by hand, right? If someone give you the host name, and or we can click on the main screen, do it just a simple, look up, type in the host name. So I'm going to look up the machines that I want to touch. I want to restart Surface. It's actually the same machine that I'm doing the demo. So once you look it up, this is the screen that we have, a simple screen to redraw. You can actually get the salt grain, peel and other informations. Now this pop-up is because, this is the reason why another pop-up show up. This pop-up show up because we have, one of the tabs that we have below is hooking up to Splunk. We actually embed the browser in there. So it will land you right at the Splunk screen with the query preloaded. So you don't have to search. You can actually look at the log for that box, right? So I'm just logging for now. And Splunk is managed by our single sign-on system internally. What I have in demo is just in the lab, so they don't cross. Salt grain, everybody knows salt grain. So basically, we have the button at the top. We have a few buttons here. You click on salt grain, we just load it and populate it. So the NOC guy will be able to see, oh, what system profile we have. And you can go through this tree manually. It's easier to look at that than a terminal, right? And at least they know this operating system profile is what type of window we're running. Same thing for salt pillar. We can load it and just populate it. If you have integrate your salt with any external pillar, actually, so this is something that we're working on. We can upgrade this screen to allow the user to actually modify the pillar information here, and then save it and ship it back to the external pillar, right? And Can you, right, Splunk log, this will take a little while to, can you just fast forward maybe a few seconds here? Yep. This is a screen I want to show. Basically, we embed the browser here with a simple predefined query to show you all the logs. So you can actually drill through Splunk because we ship all the system logs into Splunk, right? So there's nothing here, it's in the lab. But going back to the NOC guy, I want to restart a Windows service. How do I do that? We have a system service tab. Basically, we call Salt API and then hit the service. Now, reason why I'm showing here because I want to show you, I want to restart the service. So it's because the service that I want to look at is window time. It's currently stopped, right? And going back to the plugin in the video, I can look up the service from this screen, and I just simply, it stopped, you can see. I simply click restart. Restart it. Well, some of you may think that, hey, you just mock it up in your GUI, right? So let's go get, it's running right here, right now, right? So it did go, so basically, you know, what's behind the scene here is, it's basically can you pause for a second? Yeah, I'm sorry. What we're doing here is that we have the user click on that button, fire off Salt API, and then Salt API, you know, tell the Salt master, tell this minion, go restart that particular service, right? You can do as simple as cmd.run, or their module in Windows that you can actually use to restart the service, right? You click continue, and yeah, yeah.
There's a couple other things I was going to mention in here. One of the key problems that we have at this scale is managing the keys, accepting the keys, reaccepting the keys, you reinstall a minion, whatever. This is, you know, some of the other features that are in here, like you're accepting a key, you want to just do a test ping, you want to hit it with a high state, or you want to start up an RDP. So this one is a Windows minion, so you can RDP, and this is a Windows demo, but if it was Linux, you can open up a PuTTY. Right, so once this becomes your all-access panel, you highlight and do what you want to do. Anyway, so keep going.
Yep. So as I said before, right, some of you may think that I just mock them in Windows, but if there's a tab called Salt Event Logs, basically it logs all the messages going back and forth with Salt API. It's a little ugly right now, just JSON message, but at least you see that every button click or every other things that will go through from, this is all message going through to the Salt master. We have a button, just say stream, just listen to any event that's going through this box we can actually see from this screen. Just a little handy for troubleshooting. Again, this is built for the NOC guy, the first tier guy that, hey, I need to restart the system. This is easy for them. It will be easier for them because think about someone log a ticket, there's a host name, they need to go in and restart the service. They may have a problem logging into the box. They have to find out where the box is, and you may have to go through a jump box to another network, and by the time they actually need to be able, by the time they're actually able to log in the box and restart service, it may take them a lot longer than logging through this little MMC, log in the Salt master, find the host, click the button and restart the service. It's easy for them to do. So this is the little clicky GUI that Dave mentioned.
Yeah, and right? It's something simple, cutting and pasting the host name out of an email, right, into an RDP session, and then enter your credential, and then all this other stuff. It just takes time. It's just clock's ticking when we need something rebooted, restarted, and this is kind of a one view for that, right?
So done with the first video. Let's talk about behind the scene. How do we do hooking up the AD and the ACL? The ACL part that I mentioned is not. It works. I think 80%. There's 20% of the stuff that we want to expose to users, but it's not. So you can fast forward a little bit. So let's look at Salt master. The file number one look at is called LDAP in the Salt master. So at the top section of this file, you see that this bunch of parameters you have, you can hook it up to AD. All this stuff here you can find in Salt documentation is there. I'm just hooking up to a lab AD simple test environment. But one thing I want to point out is it doesn't require an LDAP username password to bind to an LDAP. Some other system may use that. Hey, I need a username password just to look up another user. We don't. Salt is great here. It just takes what you provide, the user who actually log in, to connect to the LDAP, and then reuse that connection and pull up other subquery and figure out who the user is, right? Or the groups that the user belongs to. So this is one nice thing, right? And then at the bottom, this is where the ACL part. You can see the external auth. Underneath the external auth, we have LDAP. And then we have the tag called SAC users, right? So why I have the % sign next to the SAC users? But the percent sign basically tells Salt that this is a user group. It's not a user, right? Someone you already know. And then the asterisk is just the glob, the minion glob. And right underneath here are basically all the commands that we allow the user to run if the user belongs to the set user group. Not only we can specify the command, you can specify the arguments. Think about if you expose command.run for a user to execute. That's pretty dangerous, right? The guy can do something pretty dangerous. But we can hardwire what the parameter is supposed to be. If you look at the cmd.run example here, we allow the user to run the high state, right? And if you want to give some flexibility on the command argument, you can use a regular expression like the window state apply, right? You can use some regular expression just to give the user a little more flexibility. Everything works great. Grain start item, pillar, system reboot, service restart. It works well, but so far, all these commands belong to the Salt client. There are two other clients in Salt, right? They're the wheel and the runner. There's some API we love to expose to the users. For example, I want to see a list of all the keys. I want to see a list of minions that are present, right? They're not doing any destructive things, but it is informative for the users. Hey, which minion actually present, which one is not? Apparently, we can't.
Frustratingly absent is remove key and accept key from core API.
Right. So
frustratingly. In fact, I wrote that code, and I'm the director of the group. So that's how frustrating it is that's not part of the core API.
Right. So.
And you have to be in the wheel group to run it.
Yes. So the problem here is Salt. At the point that we look at this, you can only grant the entire package a notch to the user. So for a NOC guy, I'm not going to be able to grant the entire wheel package to users to execute.
Oh, real quick, point of clarity. Yeah. SAG, Server Administration Group, NOC, Network Access Control, Network Operations Center. So NOC for us is level 1, and SAG would be level 2.
Right.
So for those of you uninitiated in the terms, that's really what we're talking about.
Sorry for the bad term.
Nope, sorry. I just figured it wasn't clear to me when I first started here.
So what we did here, can you pause for a second?
Yeah.
So what we did here is we spent a little time, spent an afternoon trying to figure out how that ACL code works, and we just monkey patch it. We just monkey patch it so that I can grant some modules and function within that client to whoever I want to specify here, right? I think there's a pull request for these features, not from me, but someone else. I hope it will be released in the future, right? So these are the functions that we have: manage.present, key.accept, key.list, all. We want the NOC guy to be able to do it, and then we also hook up external pillar to our.
Oh, we also found a very interesting bug in manage.present.
Oh yeah.
If you haven't found that, where manage.present was returning if the loopback address was available, that was tagging the minion as present. So if you're keying off manage.present, I haven't looked at the newest code, but in 2016.3, which is what we're still on, that's a problem. We had to patch it.
Yeah, that was a little mystery. It's very intelligent, the way how we look up in Salt is pretty smart. I look at what's actually connected, right? Which minion have a TCP socket connected, then they should be present because it's a pub-sub architecture. But when we look at the code, if you're not connected, the cache cell will update the IP address from mean to 127.0.0.1. So everything's connected. So I was pulling my hair trying to figure out what's going on. But we found that code. Anyway, but this is it. This is the way
we've
how.
Been doing a lot of, we've been doing a lot of our own feature development instead of kind of paying attention to what's going on in the greater community because we have problems to fix. So that's why we're a little bit behind. But if anybody else is interested in more data on these kinds of fun challenges that we found, we're willing to share here at the conf. I don't think we can do so publicly, but come see us.
Yeah, I was calling everybody in the team. I found a bug for manage.present. I remember that afternoon.
How's your new guy pass? That's how you win your new guy trophy.
Well.
Oh, whoops.
So, oops. I think I have a little. So at the end, this is just the same thing as what the MMC is doing. I'm just making a code call. Once you make the Salt API call, it will tell you what. It returns two things here, right? Two key pieces of information in this big giant JSON blob. One is to tell you what you can execute or the ACL that you're allowed to hit. You see under the perms, test.ping, all the commands and what parameters you can execute. And Second part is it returns a session token with Cherry Pie. So that session token, you will have to continue to embed in your HTTP header as an HTTP header, right? It will tell you how long it was, I think it's 20 minutes.
Cherry Pie, the best web server ever written.
Huh?
The best web server ever written.
Yeah, we run. Right. So I just
you
have
want to
it
see
run.
the puts and gets, you got to turn on full debug on that guy.
Yeah, we have it running underneath Mott Whiskey and Apache. So that we are also restricted. I mean, working here, there are certain things we can use. There's certain things we can use. I love Nginx. We love to run it under Nginx, but apparently we can't use it, so we're stuck with Apache. It's fine. We still work a little bit of time, but we're good.
Okay, next one.
All right. So this second video, simple. So that's what MMC is actually calling those API. And third part is returner. This is very useful. The most powerful thing that, I shouldn't say most powerful, but a small amount of code that we've written help us out tremendously, especially the use cases we have. When Dave and other guys in the team trying to get the system update, they're like firing out message to thousand minions, right? And there could be a lot of messages coming back. As I said, you update 1,000 minions. You want to find out maybe 950 of them works well, the other 50 fail. You want to find out which 50 fail and what happened, what errors you got, right? You want to actually look at the log. And so how do we do it? We use returner. Excel has a bunch of returners, very useful. They have a raw file, JSON, there's a Splunk returner. It's useful, the Splunk returner actually ship the message through the HTTP protocol in Splunk, but it doesn't work out, it doesn't scale enough in an SA because we could be we could crush Splunk if we fire so many HTTP messages at the same time. So what we did, we just wrote a simple log returner, basically using Python's logging module, right? Have Python logging module do all the log rotations. We set out how many you want. So when the returner start, we just initialize it. When it's getting low, we just initialize it at the bottom, and return is very simple, very, very simple, right? There's nothing, just fill out the code. You just initialize the logger, and if you fast forward just a few seconds, a little bit more, maybe. There you go. So for event return, all we're doing is we're actually logging stuff that we want to log. I mean, there's so much stuff coming back with different type of messages. We just want to look at jobs, things that the jobs runs, and maybe manage.present and other things that keep few things. So in a config file, we spell out what we want to listen, what we want to track, and then we just dump all the log file through Python's logging package. We just dump it into a JSON string and log it. And on the other hand, we just have a Splunk forwarder, like an agent. Splunk itself has an agent, pick up that log file. It optimizes the way how file get transferred to Splunk, do some crazy transformation. We ship that to Splunk directly, right? It's not almost real time, but if Dave push a button, I want to update 1,000 minions, maybe within 30 seconds, we'll see a log message show up in Splunk very quickly. So if we fast forward just a few more seconds, there you go. This is in raw form in Splunk. Splunk is JSON native. So if you parse that JSON message in regular expression, probably take you a while. But Splunk has a very nice features, nice command called spath. You can convert basically figure out the path for that tag that you want to look at, and then just use that to do any filtering. With that message show up, you can do some query, figure out what ran, and what machines, who did what. You have a job ID you want to look at. You want to know who actually fired off what command, and going back to the question I said before, I'd fire off command over 1,000 minions. Which one actually failed? Which 50 of them failed? You can actually start investing your time, build up some query, and not only I can see it, everybody in the team can see it because the same query that can be rerun, the index is shared from the team. You fast forward just a few more seconds. And you've built enough query, you can start building dashboard. Here, I can look at any single point of time that going back in time, what happens and who fired off what command, and did the job complete? And more importantly, on the right side, how many minions actually get effect from that job? You thought that when I run Salt, web dash, whatever, and you thought there's 50 web server. Oops, there's actually 80, right?
You're gonna rat me out, Hoy. Look out, I'm firing stuff off. You're gonna rat me out. I saw my name in it.
Yeah, so you can actually see it and scroll, If you fast forward a little more second, yep, I think I have one. No, I don't.
All right.
I'm sorry, but it will show you, you can actually drill down to the dashboard we built. You can see what actually failed. Look at that output from the module, the PowerShell module that these guys written. They can actually see it. So this is kind of the two chains that we have in our current state, current solutions. I think that's all I have for my video.
So I want to leave this. I want to leave the end of this one up because I want to talk a little bit more about a couple other things we built. So one of the things that are built but not displaying is that in our module that we use to use the Windows Update, also we still do offline patching because I don't know how many of you guys, how many of you out here in the audience are Windows admins? Ish. Fixing Windows Update codes that Microsoft hasn't documented is like a straight A ticket to hell. No stops on the way, right? So we still use a script that takes in monthly patches and we'll use them in an offline way to patch that. That doesn't always get us around Windows Update services problems. We've had some machines that have failed service packs installed and stuff like that. In our environment that's of our scale, you're gonna have a couple of sickos. But the Windows Update agent itself is pretty finicky. It's better on Windows 2012 R2 and 2016, primarily due to the roll-ups, but also its detection logic is a little bit more robust. So we still use the offline script quite a bit. So in order to make the Windows Update module work and the offline update script, they have to log into the same place. So when we send out we have all of our machines in two. There's a couple of exceptions, but we have them in two major windows, which are after immediately after Patch Tuesday for your dev environment, and then you're baked out for a period of time until we patch production, right? And for us, that's a very aggressive time frame, more aggressive than other companies that I've worked in. However, this is where other tools that compete with SaltStack that do patch management, where you say, well, the last time we deployed a patch, we only got 97%, and the company comes back and tells you, well, that's better than like almost all of our customers do. Well, if you take 97% and you multiply that out by 16,000 systems, how many do you have to go track down that didn't get the patch in a 6-hour window? That's a lot. So on our first pass with Salt and the offline script combined with the Windows Update stuff, and we're kind of hitting it two ways, we get a patch success rate that is closer to like 99.85. So that's a lot better. It still means that when we patch 4,000 machines, there's usually 250 that need to be tracked down for one reason or another. Something that the Windows Salt Minion just does not like is when a box is low on resource and it is crammed for CPU, it really doesn't like that, or if it's low on RAM. So sometimes we have to go reboot the box and give it another try. Not a Salt problem, just a problem with the host where it's under provision, someone's running out of RAM, those kind of things. These business intelligence tools that use every available byte of RAM in the page file to move their stuff. We see that. We see network latency at times that impacts that. We also see machines that are just sick and they don't want to patch unless you stop the Windows Update agent and immediately run the WUSA exe. And there's no other way to get around them, and we've worked with Microsoft on these, and they're all different weird special error codes, and we have kind of a known errors table of stuff, or you could have someone's turned off the TLS 1.0 client on something, and WSUS doesn't support TLS 1.2. So you run into all these kinds of issues that you have to work through with the Windows Update agent where you're still beholden to the overhead. So we still use the offline. We copy the file down, we run WUSA, we do that, but we're still having to chase down that amount. And since you can imagine at the scale, and you can infer which tools we were probably using based upon the success rate that I was telling you, but I don't believe any of those systems sold third party are materially different from each other in terms of they all need care and feeding, they all don't have 100% first pass. In fact, agents in our environment, which is another thing we use Splunk for extensively, not all agents have 100% pass. Salt isn't always working. Your antivirus isn't always working. Security scanner thingy isn't always working. Monitoring agent isn't always working. I'm trying to give you like without naming names, right? System inventory of software tool agent thing isn't working, right? So we have a team that has to do hygiene on this stuff at all times, including SaltStack. And it's no different, and even the stuff we have that scans the network, you're still not going to scan a host that's at 100% CPU. I'm sorry, it's just not happening, right? So we often find later on when we've had maintenance or things retire that we have stuff that we've missed, and it's not really through any fault of our own, it's because we have a very complex environment. But our first pass patching is really good, and we can patch 4,000 systems on Windows with all these roll-ups and every different product in the world, and it's a roll-up, but it's not a roll-up, and all that, those games that Microsoft plays, and all of the no patch fixes and all the registry stuff that you got to get your quality security scanning methodology thingy to like get your report cleared off, right? We can execute that against 4,096 hosts in a 2.5-hour period. So, and that's our production environment. Non-production happens faster than that, and we've actually extended the Salt scheduler to doing it on its own, and we've come up with built-in code methodologies to key that off of Patch Tuesday instead of a day of the week, a certain number of the day, all of those kinds of things. So we're starting to implement that across our production environment as well. So that's kind of what we do a lot. We patch, we patch, we patch. ABP, always be patching. Coffee is for closers, right? So that's how we run it. ABP, always be patching. AIDA, right? And we're doing this a lot. And it's folks that are doing automation tasks like Jenkins deploy jobs and every other tool that you've seen here we use in some form or fashion, and we use more third-party stuff than anybody's presented here, I guarantee you. And I could list off just the products I know about, but if you can name a business intelligence tool or a machine learning tool, we got it. And we may be the go-to-market partner for our industry for those tools. So all that stuff that's made by those GPU companies and the ones that make computers that play chess and all of the stuff, yes, we have that one too, right? So it's pretty challenging. We also have a hybrid environment where we have the cloud of people that sell books, and we've got the cloud of people that sell operating systems. And we have a lot of other things in between and a lot of software as a service, and you name it, we got it, right? So if there is something that thankfully we didn't have the last one that had a CVE 10 that came out this week. We don't have that product, but we have most of them, okay? So it's challenging because when you come up with new design patterns for things and you want to do a Salt State, a Jenkins job, a this and then that, it's not just a .NET application on 3 tiers and set the F5 and the network firewalls and the data power and Bob's your uncle, right? It's like, oh, this one's got WebSockets and this other one has OAuth requirements and this one's a SAML and it's challenging, right? So very complicated environment. So for the level of success that we have at 99.85, that is a tremendous achievement for how complicated our environment is. And we're also getting into now the special snowflakiness of restart orders where things don't recover gracefully from reboot and justifying why things should infinitely retry if the database is down and not just retry it 10 times if the box is rebooting, right? So we are having to do, there's some level of salesmanship, developer education, a lot of soft skill stuff that comes into making that environment true up. But when I've only got 7 or 8 of these that don't reboot correctly out of the 4,000 or something like that, it makes the majority rules a little easier. So with that, we love it. We love the control. We love being able to change things. We love being able to do what we want to do on the fly. We spot a problem, we go solve it. We don't have to get anybody else involved. That contributes to our velocity and our multiplicative effort, right? So if we can get people in positions to do their jobs faster by using our tools, that's what our next evolution looks like, and that's what you've seen today. Does anybody else have any questions or want to share an experience of their management of Windows on SaltStack with the audience? So we have an open source code. Policy that I've never had a chance to explore because, as you could probably imagine, we're kind of busy. But yes, that exists, and yes, we would love to be able to share. And we're looking to true up our relationship more formally with SaltStack as a company to be able to do that kind of stuff. So this is more ideation around what we're doing today, but we would love to be able to put some of that stuff back out. Right now, we haven't had time. It's faster to fix it and move on than it is to try and get that. Now, that's not entirely true. We have contributed a couple of things back, but in terms of big mega stuff like this, no, not so much. But some of it is very, I hated this answer at other presentations last year, but some of it's very germane just to our environment. Not a lot of customers here last year I talked to had Splunk. Show of hands, who has Splunk in their environment? So that's more than I had last time. Everybody that I talked to at the conference last time was still complaining that the Elasticsearch returner was busted, right? So that's a different, because I think Salt's moving a different level of maturity as a product, and it's seeing entryways into the capital E enterprise, right? So so now you're seeing kind of these tools come in where before it was kind of roll your own, my opinion only. Anybody else? Anybody else have an environment where they're managing this number of Windows minions? Well, I wish I could tell you it was making everybody happy, but until everything is at zero across our entire stack, our group's the only cross-functional group in operations. So we see network, we see storage, we see VMware, we see Windows, we see Linux, we see all this kind of stuff. And until that number really goes to zero for the whole entire thing, I think everybody here who's involved in that, patching is a job never done. It's much like the laundry, right? When your laundry's done, you got to take your own clothes off, put them back in the laundry, and put other clothes on, right? So it's kind of the same deal. And it's a little bit of what have you done for me lately? So it's just a constant battle that we fight to keep flat, and it's challenging. And it's never going to end. And some companies get it, and some don't. And sometimes we struggle with the vendors that are even providing operating systems to provide us the right level of documentation on the patch to make sure that it clears what the security people are telling us is being flagged. Most recently is last month.
Do you guys use the repo engine?
So the way our repo works is the PowerShell module I was alluding to before, we have a lot of things in there that are much like the things that are built into an apt-get or a yum on Linux, where things are double run safe. So if I already install the thing and I run the script again, it just skips out the irrelevant parts, or it runs my update, or it reruns a section and stuff like that. That's kind of how it started. And then we noticed that the PowerShell code to do things like copy files, do registry keys, the lines were becoming like 200 characters long to do some of the logic. So we buried a lot of that, and we have add-registry key, add-registry value, which Salt, at the time we were starting to implement this, wasn't as mature in the Windows space as I would have liked it to be, where it would try and put down a reg-sz value, and you put 3.0, and it would change it to 3 for you automatically, and a couple of things like that. So we decided we would just call PowerShell with cmd.run to do a lot of this work. So a lot of that stuff that we're doing in all of that is really, and this is the ugliest part of our implementation to date. Our Saltmasters support environments that are cross domains that have no trusts, and we support workgroup mode machines. So what ends up happening is you have to run the SaltStack minion as a local user that has the correct rights profile to be able to do everything it could potentially need to do, so that it can't run as local system because it's not using the machine account to connect back to like a shared drive, and it can't use network service because it has to do things on the local box. So you have to have like an administrator equivalent local ID. You start it up interactively because a lot of these MSI installers and all this other stuff, they need that because people, I don't know, MSI's been around 20 years, people still don't know what to do with it. I don't know, don't start me. Even, no two installs ever the same, right? So some of that goes down, and it has its own twice run safe logic and all that, install on demand and the whole 9 yards. But so we deal with a lot of that. But what we ended up doing is we wrote a state that has an encrypted key that sits on the box that is like AES-256, the whole 9 yards. And it has a hard-coded credential in it that we can change with a state at any time, but it basically uses that to connect off to the repository shared drive as a user, and then launches PowerShell against a set of standard scripts. So all of our packages look the same. It's pretty easy. You get in there and it says Microsoft Office 2010 Enterprise install.ps1, right? And they're all the same kind of thing, even for applying a patch, applying a build customization, applying a setting, running the process monitor, the kind of general purpose repository. So it's not groundbreakingly cool. It's mapping a drive and running the script, right? But we run, what all Salt does, and the way I explain it to our junior people is it's a command runner, right? It just runs the commands in the order you want them run, simple, plain and simple. There's no magic to this part of it. You know, a lot of our headaches are managing the keys, right? I've been slamming my team to just put that in a cron, and then I get told security won't like that, and then we go back into the pit of despair for 6 months while we discuss it some more. So I have the team that's doing the agent health, accepting keys all day long, where really we should be doing that. What we're going to start doing is just making an API call back to the Salt master and using the API to accept its own key when it's built, kind of in the populating as built, like pre-populating. Our environment isn't totally connected in the way where we could pre-populate keys and then drop them down when something builds like that. We have different environments. Some of them are like a general office network, and some of them are very highly segmented, firewalled up all the way up to like we can't even RDP onto the box. We firewalled it off so hard we can't even patch it, right? So we have challenges. Like I would say that the diversity of our environment would well prepare me to give anyone advice on how to manage Windows in their environment, because we have a slice of whatever your environment may look like. We've got it, for sure. Hope that answers your question. We would love to do something like a chocolatey or a nougat, but the problem you're going to run into, that we've already run into, because VMware runs their VMware 6.5 stuff in a repo, is that if you need FIPS compliance because you're dealing with the federal government, it breaks all of the built-in crypto for PowerShell. So good luck to you with that. Good luck to you with that. And what we ended up doing was downloading a lot of that stuff onto our repo, and it will map a drive over 445 just fine with a credential if you have FIPS on. But if you're trying to use stuff like get secure string, all that stuff, be ready to roll your own into the 2.0 Original libraries. Like I said, we see it all. It's a challenge. But we have fun. We have fun every day, though. I know it seems like a general complaint session, but we have a great team. We have a great team, and we love it. We do. We love it. We love it all day. We love it all weekend long while we patch, and we really do have a blast. Anybody else? Man, I cannot believe how this group of everybody here, we're the largest Windows environment. It doesn't kind of quite surprise me, but yeah, we have a large Windows environment, period. So, thank you everybody for attending.